Hey everybody, welcome back. We have another exciting expert insight series for Cisco's Observability, and I'm your host, Christopher Bonanno, joined today again by our awesome SME on synthetics, Mark Kerpiel, who has a lot of credibility both as a customer and as a customer success engineer. And again, this series is going to be more driven around demonstration, following along. We have content that you can go out to and you can start kind of implementing what you're learning as you're going. And then say that we go too fast or you miss some of it, or you get pulled away. We get it. The busy IT professional, they will be recorded and posted up on our YouTube. So I'll make sure to get that link out to you. And without further ado, go ahead and take it away, Mark.
Hey everyone, thank you for joining today's session. My name is Mark Kerpiel, like Chris said, and I'm a customer success specialist here at Cisco. And my job is to enable you on our Splunk AppDynamics product so you can get the most out of your purchase. And like Chris said, in today's session, we're doing our Expert Insight series, where we dive into important topics related to observability here at Cisco and do demo labs that you can follow along to. Chris is going to be posting our GitHub in the chat for what I'm covering today, so you can follow along, or if you want to, do it later after the session if you just want to watch me do it today. And this is the second session of our synthetic series, where we go into more in depth into synthetics by covering advanced BRUM script building. And just in case you missed our first one, we did do an overview of synthetics and then how to create simple scripts. And if you haven't seen it yet, please check out the recording, which is on our YouTube channel, which again, I'll have linked in the chat. Now, this series does build on itself, but if you haven't seen the first one, don't worry. I think you'll still be able to follow along with today's session and then go back to the first one and learn from that as well. And as well, we're going to be doing another session focused on API scripting in 2 weeks, so please don't miss that. Now for today's agenda, we're going to first dive deeper into some browser synthetic concepts that people tend to miss. Then we'll give some options for setting up browser synthetic jobs. Then we'll cover how to set up proactive monitoring properly to get the most out of your synthetic jobs. And then I'll give a demo that you can follow along to, covering all these concepts and showing you how to create your first complex browser synthetic script. And then we're going to finish with a Q&A where we'll have some closing thoughts. So yeah, let's get started. Now, the first browser synthetic feature I want to dive deeper into is synthetic snapshots. This is a highly underused feature, which needs more love for how useful it can be. Well, so snapshots are a way to take a quick snapshot of a single page using our synthetic agents to quickly get a report of that page's health. This saves us time from creating a full synthetic job where we need to run when we need to run a quick session. A good use case for this is if for those of you who rely heavily on browser real user monitoring, if you find a session that's showing an issue on a particular page snapshot, within that page snapshot, as you can see here, we can run a synthetic snapshot within a single button press to help verify if we can replicate any performance or any availability issue that a user is seeing. A good second use case is if we're doing a release, we want to verify the performance and availability of a page quickly. We can then use our on-demand snapshots to check that page for availability and its performance, as well as debug our findings if necessary. Now, the second feature I want to highlight is something people don't even realize exists, which is the Secure Credential Vault. The Secure Credential Vault was made to make sure that you're staying within your security policies, since it only allows you to store any value like passwords and then call it within the script by key name instead of calling it directly. And it only allows certain users who have the correct RBAC permissions that an admin can set to view or edit those credentials in the vault. And to access the vault, all you have to do is click on your name and then click on Manage Credential Vault, as long as you have the right permissions. And once we're there, we can either add values manually or mass import them using a plain text file, which is then sorted with key value pairs. And then to further enhance our security, optionally, we can select which application we want to use for that value. So other teams with other applications aren't allowed to use our value. That shouldn't be. Now, once we created those values, they are easy to call. All you have to use is this specific format as shown on the slide. When you enter the first two characters of this format, it will let you start autofilling as you see here, which makes it not only quicker, but also make sure that you put the correct syntax. Now, not only is the credential vault essential for your security and compliance, but an underrated use case I almost see as more important, or at least easier for us as admins or any engineer, is if you regularly make changes to key values such as passwords or usernames, you don't have to update it in every script, which I've done, and it takes hours depending on the scale of your synthetics. Instead, you would have to just update the value once in the credential vault, and then every script calling that key will be updated accordingly. Now, a lot of people don't know that other libraries are supported by us other than the Selenium library, and I want to highlight them in case any of the packages might fit a use case that you've ever thought of when creating your synthetic jobs. The first being the logging library, which I believe to be essential, so much so that I'll be showing it off in the demo later, because it allows you to make customizations to the type of error messages you output on your screen. For example, if we have a certain condition that must be met with an assertion, such as the title of our page being correct, if that assertion fails, we can then throw an error message, letting the team debugging the session know that what we're looking for and why it's failed in detail, so they can debug properly. We can also send debug logs for things that aren't breaking our script, but might be good information for the teams looking at the sessions. These can be things such as steps being taken by the script or pointing out certain aspects of your web page. Now we also have the PYSFTP library, which allows us to upload and download files using secure file transfer protocol, making it so that we can use synthetic scripts for more automation type purposes. For example, let's say we have a script that runs daily to check our UI. We can then build a report of each component we want to check and then send it to our remote repository where we keep those statuses. And then we have our Python request library, which allows us to make requests to any page we want. I will say most of the time, unless you want to tie it with a browser synthetic job, let's say we want to use a user to log in through the UI and then run an API request, which could be a good use case. But again, most use cases, if we're just trying to make a script specifically for API requests, I would rather use our dedicated API monitoring scripts since it has more features specific to APIs, and we'll be diving deeper into those API scripts in 2 weeks in our next session. And then finally, we have our PY Auto GUI, which we can currently only use in our private synthetic agent, unfortunately, but it does allow Python scripts to programmatically control your mouse and keyboard, simulating human interactions with the computer's operating system and applications. This is useful for certain use cases, such as selecting client credentials or dealing with certain annoying pop-ups that Selenium might not be able to handle as well. And then for synthetics, it's not only important to get the script correct, but it's also important that we set our jobs correctly for our goals to achieve proper configuration for any use case. And to achieve that, we have 8 options. And it's important that we consider all of them and what they mean in the context of our specific script and use case. For example, we might want to set a schedule to run only during off hours when real users aren't providing data, since we rely on real user monitoring during the day, and we want to reduce synthetic license count. Or if we want to test multiple browsers and mobile device sizes to make sure we're delivering the best experience for all users on all devices. And another cool configuration a lot of people don't utilize is connection speed. We know not everyone is going to have the best connection speed, but we still want to make sure that we provide them with a great experience. And if you don't set it, the default is going to be cable, which is 5 megabytes per second. We can also define what a good session looks like, whether it's based on pages loading properly or resources loading. And then from there, we can get even more granular, segmenting that by URL. So let's say we want to make sure that all resources are loading on a page that we've seen be problematic in the past. We can specify that. As well, we can define performance thresholds to ensure our scripts are meeting our standards or our SLA standards, such as certain visual completion time thresholds or availability thresholds. And I'll walk you through all these configuration options in the demo. And now once we set up our synthetic jobs, we will need to make the most of them by setting up proactive monitoring. And for that, we have some options. The first being custom health rules, which are almost the same as any other health rule in AppDynamics, where we define conditions to be monitored on, such as key metrics from our synthetic jobs. These can be things such as availability or visually complete time, as you see on the slide. An important thing to note, which confuses a lot of people, is that the availability metric is represented as per million instead of percentage based because the controller metrics are given as integers. But it is easy to convert that per million to a percentage. Just divide that availability by 10,000. For example, here we see 999,800. And if you divide that by 10,000, we get our 99.98% availability. And our other option for proactive monitoring is policies, where we can set actions based on availability and performance thresholds. And those thresholds are specified when doing the job configuration. By default for availability, it's based on the session status, where we can set in the configuration the default for availability. If it's a single URL job, then the warning would be a 400 response, and then the error would be a 500 response. And then for scripted jobs, a warning is if your script throws an uncaught exception or the session status is a warning. And then an error if the script is running, has an assertion failure or a timeout. And it's important to understand the differences between the warning and errors, especially when configuring our alerts. You can also alert on performance thresholds, which we'll be setting up in our job configuration. And those can trigger events when those thresholds are exceeded, and I'll show that off in the demo. But each status, availability, and performance issues will be reported as their own events, and then we can either alert on these events using our policies as shown here. Now let's go into a demo and show what this all looks like. One second, sorry. Okay, so the first thing I'm going to do is show you how to create your browser script. This is going to be a complex browser script that goes into our Swag Labs here. So this is simulating a storefront, and we're going to show you how to log in, how to check for certain assertions, and show you how to do a full checkout process from start to finish. So the first thing I want to highlight is this framework. Now this is given in the GitHub, and this is the synthetic script framework that I use because I find that I get around a lot of the false alerting that I've had in the past with synthetics. And a lot of that reason is the functions I have for finding elements by certain values such as CSS or IDs. And I do this by waiting for elements to be clickable, and then I find the element values. As well as my click element functionality, which has a Boolean value as its second parameter. And the second parameter Boolean is for a JavaScript click. So if that's set for true, it will do a JavaScript click, as you've seen here, instead of a Selenium click. Now, I only recommend to set this to true if you're having issues with a specific element. A lot of the times when you're having an issue, which is maybe 1% out of one time out of 100, this true would fix that one issue more likely than not. So that's nice. And then another thing here I have is I disable pop-ups. This is nice when you're not running it in headless mode. AppDynamics by default runs in a headless mode, so you only need this mostly for debugging locally. As well as I use a package for my WebDriver called Chrome Driver PY. This just automatically downloads a Chrome driver, but you could just set this manually and download it manually if you wanted to. Now, there's comments for everything that's going on, so I won't go in depth with everything, but the next thing I want to do is start editing my script. So the first thing we're going to do is do a logging.info. So again, I'm going to log all the steps I do. So when we're debugging, which I'll show off in the sessions, we can see the individual steps that the script is taking. So the first thing we'll do is navigating to our URL. And then we'll do driver.get. I'll copy our URL, which is the sauce demos. Now, the first thing I want to do is, thankfully, this demo shows you what a locked out user would look like. So I want to replicate that by going and entering in the username and password of a locked out user. So I like to do this manually by inspecting the element, then looking for unique identifiers of that specific element. The more unique they are, the better. And the first thing I always check is the ID, as it's usually a unique aspect that won't change based on the browser or the view that you're looking at. So we see this unique identifier username, easy to find, and then we're going to be using our find element by ID function. See, Copilot's figuring this out for us already, right? Send keys, which is the standard Selenium way to send an input, and then we'll grab that locked out user, and I'll do this manually as well, so we can show you what it looks like. And then we'll do find element by ID. It's already looking for it, password, and then same thing, the ID is unique here with the password. And then dot send keys, and then the password, which is the secret sauce. And then if we do that manually on the site, you'll see that we get this error, epic sad face, sorry, this user has been locked out. And the thing we want to do here now is assert that that message is appearing. So we do want to click on the login button first. So look for that element, login button. And then now we're going to verify that this is showing up. So I'm going to do a logging.warning. We're going to verify that the error message is being displayed. And then we're going to look for, now I already know that this container, this H3, doesn't have a specific element. So if you look at it, it doesn't actually have anything unique to identify by. And I was already testing this from before. So I actually had to use the XPath here. This isn't best practices, but sometimes you don't have any other option. So we're going to find this element by XPath. Just to verify that it exists. And then the next thing we're going to do is assert the find element XPath dot text. And sorry, that's autofilling for me, but normally you just grab that text and then match it up and assert this. Now, AppDynamics, if any assertion isn't true, will automatically see this as a failure. And I'll show this off in the demo. But this is where the availability metric would be affected by if this wasn't true. And then the next thing I want to do here is I'm going to take a screenshot. So, and then log.info.warning, user login message verified successfully. So we took a screenshot here, and I'll show this off in the demo, showing that the user message is correct. This user is supposed to be locked out, and that's working properly. So the next thing I'm going to do is do a logging in. I'm going to log in using the right password. So logging in the valid user. Don't forget your info. And then we're going to do a driver.refresh. I'm just going to do this to reset everything. You could just clear the values as well. I just find this a little easier. And then the next thing, again, we're going to go to that username. refresh this. And then we're going to enter this time standard user and secret sauce. So we're actually just going to copy that, what we did before, but then just change this to standard user. Okay. And then if we do that manually, we're then greeted with our storefront. So this is the storefront we want to start going through. The first thing I want to do is add this Sauce Lab backpack to cart. So first thing we'll do is verify that the ID, or sorry, we'll look for a specific unique identifier. So we're going to use this ID. We're going to do logging.info, or that autofill, adding backpack to cart, and verifying remove button display. So we'll do find element by ID, cart, and then we're going to do the click element. Set this to false. Ignore these trues, sorry, these were supposed to be falses. And then the next thing we'll do is an assertion to make sure that the remove button has appeared. So if you add it here, you'll see that this button's been updated. This element is what it's called now, this remove Sauce Labs backpack button. So we're going to be doing a assert find element by ID text is equal to remove. And then we'll do logging.info. And the next thing I want to do is click on this Sauce Labs fleece jacket. So we'll inspect it. We'll see that we have a unique identifier here. But it's called itemified title list. And I'm not sure if you were a developer, maybe you'd want to use this because you know that item 5 is always associated with the fleece vest. But since we're not entirely sure of that, I would rather use this link text because it's unique and it actually identifies the fact that it is a fleece jacket. So we're going to do logging.info. Buying fleece jacket. Click element. Find by link text. And then set that false. Okay. And then if you manually click on it, the next thing we're going to do is now verify the price of this. So we'll look for that price item. And we're actually going to do this by class. So if you look at what actually has the text here, the only unique identifier I see here is this class equals to inventory details price. So I'm going to look for that. Logging.info. Price of jacket, $4.99. X is equal to $4.99. Okay. Now once we do that, then we're just going to add it to cart. So again, we'll look for that button, unique identifier, and then use that. Okay, and then once we click here, let's now go into our checkout and see what this looks like. So we're going to go, again, we're going to do it by class. So we're going to click, oops. So clicking on cart item, and click element, finding by sharp cart link. Verify that's correct. and then we'll do our checkout process. So we'll click on our checkout button. Just to save some time, I'm not going to log every step here. Just to save you guys but in the actual script that I have on GitHub, it does show you me logging all these steps. I'll just say checking out, save us some time here. And we'll do click element, element by ID, checkout. And then we'll enter our first name, last name, and zip code. So for each of these, we have a unique identifier. We have our first name ID, our last name, which is an ID, and our zip code, which is an ID. Thankfully, that makes it easy. So we'll just make it quick, nice and simple. We're just going to use test 000 for the zip code, and then click on continue. Okay, so now we can verify everything looks good. We'll click on our finish button. Again, to get the unique identifier, easy, it's our ID is finish. And then we would just want to verify the thank you for the order. So for this one, I just looked for a specific ID that we can look on. So I do believe it's this one. So yeah, so I looked for this specific class name, complete text, this checkout complete container ID. So I looked for this specific ID. Now, if I was a developer, I would know specifically if this checkout complete container means that it's proper thank you for the order or not. Since I didn't develop it, I wouldn't know, but I think it's a good guess that verifies that the order is correct. So we'll just put that last step in. And now let's quickly run this locally and show you what that looks like. So I'm going to quickly do this. Quickly send a breakpoint. This is another reason why you should be using an IDE, is that you can create specific breakpoints and test individual steps. So this is our screen here, and then I will quickly start it. We can see our steps being taken. Oops, sorry. Where we lost that, there we go. As you see, you can see the steps being taken now. So that was really fast, but you saw it go through the login first on the failure, log in properly, add each item to cart, going through each item and verifying all the assertions are done. And now we're good. And if you look back, you see that the script's been completed. So now that we have our script completed, let's grab it and let's actually take it into AppDynamics, where we can run it as a job. So now walking through some of the configuration options we have. Here we can either do the first option is measuring either a URL or a script. In our case, we're running a script, but if you wanted to just run it against a single URL, you could do that as well. We're going to do the script, and with my template, there's a few things you need to comment out, and thankfully there's you can see here that there's comments on what you want to do. So the first thing we're going to comment out is the Chrome driver package. We don't need a Chrome driver since AppDynamics will create the web driver for you. And then same thing here, we can comment this out, as well as the Chrome options. Again, this will be ran in headless, so a lot of the pop-up options that I have here don't matter as much when you're running in headless, and you won't see the issues that you have running it locally, which is nice. You want to name your script, so I'm going to call this EIS Series 2. Live. And now we can choose between private and hosted synthetic agents. For hosted or for any of these use cases, you want to consider where your users are coming from. Let's say we have a site that's only available in North America. This is where you'd only want to select and replicate that. But if you have it globally, you'd want to select as many as you can to see if there's any specific locations that are affecting or your website isn't being consistent with. Then you can select all locations every time or round robin. If you're running regular intervals, I recommend round robin, since if you do all locations, especially if you have a lot of locations selected, you will be eating up a lot of license count. But let's say you only run the script maybe twice a day, then it might be better to use the all locations. Then we can set our custom schedule, and you can get quite custom and granular with this. So the default is every 15 minutes, but you can specify hours, days, specific time zones. Between hours, like I said, maybe you rely on real user data during the day, but want to use synthetics to supplement real user data during off hours. You can specify specific days or days of the week. Again, to supplement real user data, maybe you don't have a lot of users logging in during the week or during the weekends, so you want synthetics to cover that. You can select multiple browsers. You can select Chrome versions, Firefox, Internet Explorer, and different mobile devices, including the height, width, and pixel ratio. And you can see some of the presets, such as iPhone 7 Plus. Connection speed, like I said, not an underutilized feature, but you want to ensure that your site is working properly for all connection speeds. So this is a great customization that you can do. Timeout period, for timeout period, it's really about balancing. If a script times out, it does count as a failure. So you want to have this high enough where it doesn't cause false alerting, but low enough that it actually catches a proper timeout. And if it's too high and it isn't catching the proper timeouts in time, you're going to be eating a lot of license blocks, which could be costly. And then the last two, availability rules. So this would trigger any availability metric trends and affect your availability metric itself. So you can change whether a page failing to load is treated as a fail, or you can ignore it, a resource, or triggering an event for a failed session. You can do an immediate retest. You can do a few consecutive failures if you have, maybe you're running this very often and you're kind of expecting some issues. And then you can ignore resources when a URL contains a specific naming convention, or only consider it. Like I said, maybe you have problematic URLs and you want to either ignore them or include them to check them. And then the final configuration setting we have is performance thresholds. Now for performance thresholds, this you can set specific thresholds such as end user response time, visually complete time, render time, and then as well do automatic retests if you have an issue with it. And then these will trigger specific events that I'll show you that you can alert on. Now you see I have 3 versions of the script I created. The first one is a properly working one. So if we look at this and kind of show some of the best practices that we had, you see that we're outputting all the information that's necessary, such as navigation, adding items to cart, and verifying everything. We can look at the screenshots we took. So we specified taking a screenshot after that locked out user fail. So we can see exactly what our screen saw. And then best practices, something I include in our in the framework that I gave you, is taking a screenshot when there's a success. So you see this is the last screen we saw before the script ended. Now in contrast, this one is broken on purpose. So this one I'm doing the assertion incorrectly. And if you see here, we can see the last step it took. So we're verifying that our error message is displayed. So we can look at this script now and see, wait, why is this failing? We know the exact step it went, so we can narrow it down. We want to look at, here we go, the verifying error message is displayed. And if we look at the error message, it's saying test. We know that's not the error message that we set. So we can then debug and change the script to update it to work properly. Now, the next thing I'd show you here, and an important thing to note here, is that specific script failure is causing availability to be broken. But this performance threshold that I set is affecting the performance trend, but not the availability trend. So they are two distinct metrics that you want to take advantage of. So you see here, I have performance threshold set, and I have it quite aggressively here. If it's the visually complete time, which If for those of you who don't know, visually complete time is the complete time from start to finish of the script without including the startup and spin down of the specific VM. So that's important to know. That's basically how long that script actually took to run the steps you have. And then I have an insanely low threshold of 1 millisecond just to show you those failures. Now, the next thing I want to show off is our credential vault. So if we go into our CS demos, we can actually create credentials that we can call in our script. So let's set one for username, and then we'll call it standard user. And then optionally, we can set which application it belongs to and hit OK. Now, if you want to go back to our session, to our script, and then use that specific function, let's scroll down to our username where we entered it. And then instead of using the direct input there for standard user, you do that key percentage, and then now you can kind of see which options you have. So we want to use our username, that'll autofill, and then now you can have specific users create scripts and not have to know the username and passwords if that's a security compliance issue. Or again, if you're updating your passwords or users' names regularly, you can update it once in that credential vault, and every script calling it will then update for it. Another page that a lot of people don't use is the pages part of Synthetics. So you can actually look for specific pages and how the performance looks like across multiple jobs. Let's say we have hundreds of scripts and all of them go to the base page of sauce demos. As you saw there, we have 4 scripts going here. We can see the page performance completely at a high scale. So we can see the timing breakdown, average user response times, key performance metrics, and we actually can create alerting and dashboarding purely based on the page, not just the script itself. And then I talked about on-demand snapshots. So these are ways to make single ran sessions on individual pages. So you could do something like google.com, select your location and browser, and then generate a snapshot. Now, as that's running, I want to show you on the BRUM side how you could do this as well. So if we go into our user experience and go into the browser side and go into sessions, if we find a specific snapshot that's throwing an issue, that means our users are a specific user had an issue on this site. We can then generate a synthetic snapshot of this URL directly from the BRUM session and see if we can replicate that locally with any of our browser synthetic agents. Now going back to our Expert Insight series and then to our on-demand, this is what the session output will look like. So you can see our page performance. We can see that our user experience is normal. We can see how long it took to load and that all our resources were loaded properly. So you can see that all our resources look fine. Everything looks great. And maybe it's specific to this user why we're having issues. Now, the next thing I want to cover is proactive monitoring. So we have our health rules. So our health rules, we select synthetic jobs in our affected entities. And then we can set specific criteria. So in this case, we want to check against availability and make sure that our job is running at a 99.98% availability or higher. And if it's not, then we want to trigger an alert. Same thing with visual complete time, but this time we're going to do it against our standard deviations of baselines. And if we have a huge deviation of 3 standard deviations, we want to alert on that. And you can see here that the 2 scripts that we purposely are breaking are showing as unhealthy because of this health rule. Then I want to show off policies. So this is where we can trigger on synthetic availability issues or performance issues. So we can see if there's any warnings or errors started. As well, for any health rule that we create for synthetics, this is where we can trigger on those and set our health rule scope. We can specify which synthetic jobs we actually want to alert on, and then take action from there. And if we go back to our synthetic jobs and go into events, this is where we can see any events from performance and availability. And these are the events that we can create our policy to trigger on. So you can look into this. You see that our fail on purpose continues to exceed the threshold of 2 milliseconds 6 times for visually complete time. You can dive into more details from there, as well as copy this link and send it to anyone who might want to troubleshoot on this issue. And then the final thing I want to show off is our dashboard. So this dashboard template I actually included in your GitHub repo that I shared with you. So if you want to import it, all you have to do is click import and select the JSON. But this just highlights some of the important things that you want to monitor on your synthetic jobs. So we're looking at availability here and comparing it to the baselines of previous. We're looking at our key health rules for synthetics. We're looking at billable time, which is determining how much license count you're using. And then we're also looking at session results, seeing if here we have OK sessions and our broken sessions specified by the job. So this is just a high level, good, easy overview of your synthetic dashboard, just to give you some ideas when you're creating your own dashboard. And I know I covered a lot, so I did want to go into with some closing thoughts and kind of review what I talked about here on our Synthetic Expert Insight series, session 2, Advanced BRUM script building. So in today's session, we went into some more advanced synthetic features and covered synthetic job configuration options, as well as how to set up proactive monitoring. And then I showed this all off in our demo, including showing you how to create your first more advanced BRUM synthetic scripting. Hopefully you all enjoyed today's session, and we will be having that session 3 on API scripting, so please don't miss that. But before I finish, I did want to do a Q&A. I'm sure there might be a lot of questions, because I covered quite a bit. And if you have any questions, please feel free to leave them in the chat. Give everyone a few seconds here.
I haven't seen anything come through.
Okay.
Is everyone okay out there? Everyone clear on what we covered today? Don't worry, there is a recording that will be sent out, but and if you don't have any questions, we always appreciate feedback too. This series is built on content that we get from users like you. So if you have any questions, or are these API deployable and manageable?
Yes. So you can there's a REST API on the back end of Synthetics. So if you wanted to, when I was a customer, we had a situation where we had a repo of synthetic jobs. And then every time that repo was updated, it would run a GitHub action where it would send an update the scripts that you updated within the GitHub repository on the AppDynamics side. So you can do quite a bit with the Synthetics REST API built into the AppDynamics controller. Rob, is that what you're thinking of? Just want to make sure I answer your question correctly.
So basically, you have a couple different options. You can either manage it all through the UI of the controller, or you can keep everything in a repo and make it run on a cron job where it can check what's in the controller and pull it down from GitHub occasionally if anything's changed. So you have a couple different options to maintain it. Okay, Rob, okay. What methods, destinations for exceptions exist?
Anything given in the Selenium or default Python exists. So all exceptions and errors default by Python and Selenium are given, and then you can log technically any issue. It's kind of there's almost there's not a lot of guideline because Python and Selenium are so open. You can kind of do whatever you want if you have a specific use case. It's pretty. And then Rob, we do have native gateway to ServiceNow. We have a alerted, you can make custom actions using HTTP requests to ServiceNow and then create, either create tickets or update tickets based on your alerting. So the policies that I showed you that were set up, you can link those to actions, HTTP actions, then to ServiceNow. Chris, I don't know if you want to have anything more and expand on that.
No, I thought that was a really good explanation. Does that answer you, Rob?
Cool.
Anybody else? While you have an expert's ear or eyes? If there's no other questions, Mark, do you have any other closing thoughts or?
So I want to thank you guys all for joining today's session. As a reminder, this is part 2 of 3. And in the next session, we're going to dive deeper into API synthetic monitoring, which is going to be on the 24th of July. So please register and attend. I look forward to seeing you there. And if you want any more content like this, including today's session or previous sessions, we also have a YouTube channel where we dive deeper into synthetics and other topics regarding Splunk observability. So please check it out and subscribe if you like it.
Thank you so much for helping us make this a success.